Database Foundations. Introduction to Databases. Starring Neelan's Indian doppelganger, whose name is coincidentally also Neelan. Hey guys, I'm Neelan. Neelan from America's Indian doppelganger. So Neelan passed off tutoring you guys about SQL Server databases to me. I too am a database professional. He said it was because some weird dog in a trench coat was following him around, and he wanted to lie low for a while because the dog was making him nervous. I figured it was that troublemaker Jarg. I met him while backpacking through America. He was staking out a lawnmower that was left out during the winter. He kept claiming that there was some meaning behind it. I never followed up whether he got anywhere with that. I gave Jarg a call earlier, and I was right. He told me about Neelan, and he also told me about those words Neelan was saying and he was telling you folks about. So, I sort of know where he's coming from. But for now, I'm going to explain to you the foundations of database theory to continue on where Neelan left off. This is going to include what a relational database is, why it's used, the different types of relational databases and why they are used. A key component of relational databases, the table, its elements and what it represents, the concept of indexes, normalization, and much, much more. So fasten your seatbelts and get ready for a wild ride. Pull out your pen and paper. I hope you start taking notes because they'll help you learn the material and remember it, which is most important. Well, the first term of the day is, what is a database? A database, according to Google, is a structured set of information or data held on a computer that is accessible in various ways. The next word, relational database. According to Google, a relational database is a database structured to recognize relations amongst the stored items of information. A key quality of relational databases is that they store information in objects called tables. So databases, while they might not be relational databases, a relational database is always a database. So there are types of databases that are not relational. So you might be asking yourself, if you're someone that's been out of the loop for a while, why should I use a database? I got a file cabinet, I have a notebook, it's good enough, right? Well, let me tell you why. Because in a database, all data is digitized. So what that means is that you can use a program to go through all that information within seconds and do a lot of the redundant tasks that you would do while going through actual paper files within seconds. So the fact that this information is in digital form gives you a lot of flexibility with the potential of what you can do with it without the need for human intervention. Amongst relational databases, there are two main types or categories that the databases fall into. The two categories of databases are OLTPs and OLAPs. OLTP databases, or the more commonly created type of database, is short for Online Transactional Processing Database. OLTPs are the databases that are behind websites, computer applications, and in general is more widely known about and built. A key feature of this type of database is that the database constantly has its data updated, modified, and interacted with. These databases tend to be smaller and less complex than OLAP databases and are modeled and optimized to deal with transactions. A transaction is basically an exchange or interaction between a system and a person. For example, an insert, update, or delete of data within the database. Thus, in order to deal with a larger amount of people interacting with the system at once, special considerations have to be taken when modeling this database. Otherwise, the database will be less capable of handling a high number of people interacting with it. Examples of OLTP databases include the database behind Amazon's e-commerce website, Facebook's social networking websites, and most websites in general. OLAP is short for Online Analytical Processing Database. People also use the terms data mart, data warehouse, and report generating databases. These terms will be discussed in future videos interchangeably when referring to these types of databases. However, in reality, these are subcategories of OLAPs, and it's not the same thing. Businesses often request an OLAP/data warehouse when they want a single accurate source of truth that different departments pull reports from. Why? Because without a warehouse, different departments often utilize different data sources. Furthermore, their reports are often in Excel, PowerPoint, or other file types. This results in report logic and data that gets changed as it flows from person to person, and different versions of the same report existing amongst different people as the report gets fixed. Then when they go to meetings, and if this report's data is inaccurate, the trust is questioned of the department that supplied the report. If this report's data is fed into another report, and the report's data is faulty, increased data anomalies in the data as it is processed increase, and the more processing it goes through as it flows from department to department makes the data in the downstream departments more faulty. Furthermore, as organizations get significantly larger, the data sources might actually be getting created redundantly amongst different people and departments. So, by using a single source of truth for the data, you might actually be exponentially reducing workload. By having a single warehouse as a source for all reports and a reports website to display the reports, all departments will know that the data source that is being pulled from and viewed is of the same version, from the same data pool, and is not being changed or manipulated by some unknown person. A key feature of OLAPs is that they are optimized and designed for complex read and insert operations. Their main task is reporting in order to guide business decisions. Oftentimes, multiple systems will feed into this database type, and consequently it can grow massively. OLAPs tend to be more complicated to design because data quality is very important, and many systems and departments will pull reports based on this data that will guide business decisions going forward. Any shortcoming in processes or inputs that are not handled by the upstream systems often get handled and brought to light while designing and building reports off this type of database. Fixing those processes and improving the quality of data that is tracked by the company allows for rapid, high accuracy report building at a moment's notice if the report builders are correctly trained. OLAPs are known for storing historical data and integrating data from different systems. It is often not updated as frequently as OLTP databases because of the massive amount of data that gets pulled into them. In the real world, there are deviations from these ideals that exist in already built database systems. However, I will comment on the reasons driving those design deviations in a future Mindbenders episode. Going forward, from now, we will be focusing on OLTP databases, their design, and the foundational concepts related to them. I decided to toss in a slide in case you didn't know what a report was. I'm assuming we all do, but below is a snapshot from the reporting software you will be learning. It is an example of a report that pulls from a database and consequently reflects the data in that database. So every time the report is refreshed, if the data changes that is underlying that report, it will be reflected on this report real time. Whew, we went through a lot of material just now. In the last 9 minutes, we've covered what a database is, the types of relational databases. I've even given you an example of a report that will be capable of making with the technologies I'm going to teach you in the future. And in the next 2 or 3 lectures, we'll be covering what tables and indexes are with relation to relational databases. We'll be doing a few simple queries to get you accustomed and introduced to the T-SQL language, and then we'll head into OLTP data modeling. So stay tuned and get ready.